Hello everyone and welcome. In this video we are going to be talking about the difference between torque and horsepower, and we're not going to be using any strange analogies and very minimal math, just talking about theory and keeping it easy to understand. So we'll start things off with torque. Torque is simply a force applied at a distance. So you can think of it as a twisting force. So if you're trying to tighten something down using a wrench, you apply a force, you press down at a distance, the length of that wrench, and that supplies a torque at whatever you're tightening. Same idea with a socket wrench. So if you're tightening down a bolt, you apply a force at a distance, and that supplies a torque to that bolt to fasten down that bolt. Now the same thing is happening with your engine. So combustion within your cylinder is what's supplying the force, pressing this piston down, and then that piston is pressing down on a crankshaft. So as you can see, you've got your force pressing down, you've got your distance where it's pressing on the crankshaft. The axis of rotation is this center here. The piston is pressing offset from that center, so at a specific distance, and combined that gives you your engine torque. Force pressing down at a specific distance, that gives you a twisting force. That's the torque that your engine is making. Now, torque can be manipulated very easily by using gears or by using leverage, for example. So this will supply, with the maximum amount of force I can supply to it, a certain amount of torque. But then if I were to use something much longer, now I have more leverage, I can press at a greater distance, and since torque is force multiplied by distance, the torque here is going to be significantly greater. Okay, so what is power and how do these two relate? Well, power is the rate at which work is done. So what does that mean? Well, if I move this car from here to here, I've done a certain amount of work. I've moved this from here to here. Now, if I do it very slowly, it doesn't require much power. If I do it very quickly, it requires more power. Now, ultimately, I'm accomplishing the same thing. I'm moving the car from here to here, but I'm doing it faster. The rate of work is greater, therefore it takes more power. So more power going quickly than going slowly. So power ultimately is what gives you speed, what gives you acceleration. Now the two are connected. So in our context here, looking at our engine, we have torque as a force pressing down, acting at a distance. Well, how fast that's happening is our power. So that's our RPM. So horsepower is torque multiplied by RPM. So how often this interaction is occurring, and so how fast is this spinning while we're still getting that consistent force acting on the piston. So the faster it spins, supplying that same amount of force at that same distance, the more power we're going to make. Okay, so how about an example to help explain things further? Let's say we have two different vehicles that are exactly the same. Now I know these look different, but we're just going to pretend they're exactly the same. Nothing about them is different, except this one has 200 horsepower and 100 pound-feet of torque. Those are the peak numbers. This one has 200 pound-feet of torque and 100 horsepower. So half the power, twice the torque. This one has twice the power, half the torque. Which one is going to accelerate faster, assuming both of them have the same mass, and everything else about them is equal? Well, the one with more power is always going to be quicker, because that is the rate at which work is done. That's how quickly it can accomplish work, move something from one place to another. It can move it faster. Now this one has more torque, great, but as we know, torque can be manipulated through gearing. So gears act just like leverage. So while this doesn't have as much torque as this, if I'm applying torque to something, my power doesn't change. How strong I am doesn't change, but I can use leverage just like cars can use gears to make more torque. So this car with twice the power but half the torque can use gears to accelerate faster. So it can use a longer, leverage arm, a more aggressive gear ratio so that it can put that power down. And ultimately, because it makes more power, it can do more work more quickly. It will be the faster car. Okay, so now let's talk about horsepower and torque curves, because when a manufacturer gives you a horsepower and a torque figure, they're just giving you the peak figure for each of those. They're not giving you, the amount of torque that produces across all of the engine RPM range. And so if you look at a torque curve, it'll have some peak along that curve with respect to RPM. So that's the engine RPM in which the force pressing down on the piston is at its greatest. So that's peak torque. And what that means, if you stay within a set gear, if you're in one gear, let's say you're in third gear, you will feel the force pressing you against your seat will be the greatest at peak torque. Now that's assuming you're staying at a constant gear ratio. You're staying within one gear. So now, if you look at the horsepower curve overlaid over that torque curve, at some point, peak horsepower will occur. And that's when the engine is doing the most amount of work it can do. And so at this point, you may think, okay, if I want to accelerate fastest, I need to be at peak torque. So you want to be at that peak spot. Well, that's only true for a set gear. And that's only within that gear. If you can manipulate the gear ratio, let's say peak torque is right here, but peak power is over here later in the RPM range, you can sacrifice torque but get a more aggressive gear ratio and ultimately accelerate more quickly by accelerating at peak power. So why is that? Well, that's because you're multiplying your torque by the gear ratio. So you have peak torque multiplied by a lower gear ratio versus a lower torque but multiplied by a significantly higher gear ratio at peak horsepower. That will give you your peak acceleration. So for example, CVT transmissions, which can adjust the gear ratio constantly, if they adjust that gear ratio to maintain the engine at peak horsepower, they will accelerate the fastest, rather than if you were to manually shift gears or have an automatic transmission which shifts between gears, and you'll feel that peak sensation, that peak force against the seat at peak torque as you cross over it, but the actual true amount of peak acceleration that's possible with that engine would be if you manipulated gearing, if you manipulated leverage to allow you to be at the highest horsepower level with the most aggressive gear ratio possible. So a quick review. Torque is simply a force acting at a distance. Horsepower is how quickly you can accomplish work. Now, both of them require each other. They're a function of each other. Horsepower is torque multiplied by RPM. So you've got a specific torque, and then you spin the engine at a certain speed, that will give you power. And so ultimately they require one another. You can't have horsepower without torque, but the most important figure if you're looking at how fast will a car be able to accelerate, what will its top speed be, that comes down to power, because that's telling you how quickly can you accomplish a certain amount of work. So hopefully this has cleared things up, the differences between torque and horsepower. If you have any questions or comments, feel free to leave them below. Thanks for watching.